The first section in Chapter 9 is on geometric sequences. Back in Chapter 3, actually specifically Section 3.6, we learned about arithmetic sequences. In arithmetic sequences, we were always looking for a common difference. How do we go from one term in a sequence to another? And it was solely by adding or subtracting to find a difference. There was no multiplying or dividing. It had to be, in order to have a common difference between the terms, you had to look for where did you add 2, add 2, add 2, add 2, did you subtract 3, subtract 3, subtract 3, then you knew you had an arithmetic sequence. So that was what a common difference is. So there are some similarities when they use the vocabulary words for terms and sequence, but no longer do you have a common difference. What you have now in geometric sequences is what's called a common ratio. So now what you're looking for, instead of adding the same term, what are you multiplying every term by? And sometimes those terms are fractions or decimals, nothing crazy, but you could be multiplying by something by 1/2 or 3/4, which if you multiply by 1/2, that's the same thing as dividing by 2. So it depends on how you want to look at it. Are you, team multiplication where you're multiplying by 1/2 each time? Or are you on team division where you're going to think of it as dividing by 2 each time? So it's up to you. I'm more of a team multiplication. I like multiplying better than dividing. But sometimes I have to use division even to find out what I'm going to be multiplying by. So for this, also common ratio, I don't know where, the R comes from ratio, but it is, the common ratio is used as R. That is that term. They use R in any of the formulas in order to determine that that's the common ratio. Okay, so for the first set of examples, they want me to find the next 3 terms in each geometric sequence. Now, it's not a mystery here. I already know that it's a geometric sequence. So I don't need to go out on a limb and try to prove that it's a geometric sequence because they already told me it is. So I know that there's definitely going to be a common ratio. I just have to be the one that has to figure it out. So again, you can decide if you want to multiply or divide. To go from 1 to 3, again, I'm looking for multiplication or division. Here, the numbers get larger, therefore, this one would definitely fall into place of being multiplication. So here, I'm multiplying by 3 each time. What that means is that my common ratio is 3. To find the next 3 terms, I would do 27 times 3. What is that? 81. Then I'm going to do 81 times 3. Get a little help from my calculator. 243. And then I'm going to take 243 and multiply that by 3. And I get 729. So my next 3 terms are 81, 243, and 729. Okay, example number 2. You notice here it goes negative, positive, negative, positive. In order to get that kind of sequence, that means that whatever you're multiplying or dividing by, or your common ratio, is going to be negative. That's the only way that you can alternate between positive and negative. Also, in this one, you can see that the numbers are getting smaller. When the numbers are getting smaller versus in this first example, the numbers are getting bigger. What this means, if you're a multiplier, if you're somebody who would prefer to multiply, that means you're multiplying by a fraction. How you would get this fraction, you have to do a little division. I told you even if you like multiplying, you'd have to divide here. You are going to take your second number and your second term, divide by your first term. This gives me negative 1/4, or if you want, negative 0.25. So each time I'm multiplying by 0.25, or I'm multiplying by negative 1/4 each time. So my next 3 terms, my common ratio is negative 1/4. Again, it's okay for you to use the negative 0.25. However, if this is multiple choice and they don't give you decimals as options, then you have to go back and be able to convert it to a fraction. So I'm just going to stick with the fraction. My last term was 1/4. So I'm going to take 1/4 and I'm going to multiply that by my common ratio of -1/4. That gives me -1/16. Now again, if this was multiple choice and they didn't give -1/16, if they gave the decimal version of that, which is -0.625, that's what you got, and they gave the -1/16, you just have to take that extra step to convert it to the fraction. All right, my next three terms. I only found the first one, so my next one, -1/16 times -1/4. I'm going to multiply that, and that's going to give me +1/64. Then I'm going to take 1/64 and multiply that by -1/4. That's going to give me -1/256. These are my next three terms. That would be my answer. All of that other stuff is just work. Okay, number 3. Again, I'm going from bigger to smaller on this one. So with the multiplication, I'm gonna multiply by the same number. So I gotta figure out what that is. So to go from these two terms, between these two terms, I know that my common ratio is going to be a fraction. It's going to be less than 1. So how I'm gonna figure that out is I'm gonna take the second term, put it over the first one. Technically, you could do the same thing here. You're gonna get the same answer because again, they told me it's a common ratio. So I'm just doing the first one because that's the first terms. If you wanted to do two later terms, you could. You just want to take the one that comes after and divide the one that comes before. So again, if you wanted to use your calculator and you go ahead and you type this in your calculator, 384 divided by 512, that gives me 0.75. So does this one. Again, I'm going to stick with the decimal, not the decimal. I'm going to go with the fraction of each one just in case. Again, you can always convert it. You pick whatever easier for you. So, actually, no, since we did the last one with the fraction, we'll do this one as 0.75. Plus the numbers are big enough where it'll be a little bit easier. So for my next three terms, I'm going to take 288 and I'm going to multiply 0.75. So if you are going to use a decimal, this one gives me 216. Then I'm going to take 216 and multiply by 0.75. That gives me 162. And I'm going to take 162 and multiply that by 0.75. And that gives me 121.5. And those are my three answers, the next three terms for that particular problem. Okay, now, this is great when they're just asking you for the next three terms. If you remember from arithmetic sequence, they could ask you for the 55th term. Well, if you're using this method, finding the 55th term is going to take you a very, very long time. So there is this magical little formula here. If they want something that is farther down the road than the next three terms. Or sometimes they don't give you all the terms, they might just give you the first term and you have to find something in the future. So this is the formula that you would use. The formula, AN equals A1 times R to the n minus 1 power. Broken down, a to the nth power. That was the same with arithmetic sequence. That's what term do they want? Okay, if I said the 55th term, what is the 55th term? That is what you're trying to solve for. A1, which again, sometimes they do refer to it in that technical term. They use it as A1. That is your first term. R is your common ratio, and then that is being raised to an exponent of whatever n minus 1 is. It's always you're subtracting 1 when they want this common ratio. It's minus 1 because you already have that first term. So let's try this. In this example number 1, it says the first term of a geometric sequence is 128. That right there, let me get rid of my highlighter here. That right there is the A1. The common ratio is 0.5. That's my R. What is the 10th term of the sequence? 10 is the n value. So now I'm going to plug this into the formula. So I'm going to take my first term, which is 128. I'm putting parentheses around it because it's multiplication, so that just kind of, and that is not being raised to the exponent like the common ratio is. So that's why I put parentheses around it. Then I have the common ratio of 0.5. That's my r. And then I'm going to plug in 10 minus 1. Again, I know you could probably do 10 minus 1 in your head. I'm being dramatic here by multiplying this all out. Or writing it all out. Now, this is where you have to type it into your calculator. And you would type it in with the parentheses, or you'd have to do it in 2 separate steps. So 128, you could just put the 0.5 in parentheses, or put it exactly the way that I have it written. And you get an answer of 0.25. Test it out. Make sure that you're able to type that in your calculator, or it's something we'll go over in the Zoom meeting. Okay, next one. Here they straight up give me what each of the numbers is going to be. A1, which they tell me is 8. That should actually have the number 8, not written out like that. And R equals 3. R is your common ratio. Fifth, and then they want me to find the fifth term. So that is the N. So I'm going to plug this into the equation. 8 is my first term. R is my common ratio. And N is going to be 5. So this is 8 times 3 to the 4th power. This one isn't as crazy as the numbers, so you could probably maybe even do some of the math in your head. 3 to the 4th times 8. Make sure that you're doing your, please excuse my dear Aunt Sally, your order of operations, and that you do not multiply 8 times 3 first and then raise it. What you need to do is you need to do this exponential part of the problem first, then multiply it by 8. Or again, type it in the calculator exactly the way that I have. And when you do that, you get 648. Again, test it out. Make sure that you're able to get 648 because there is no other answer besides 648. If you're not getting that when you type it in the calculator, that means you don't have the correct parentheses in it, or perhaps you didn't raise it to the correct power. Maybe you forgot to subtract 1. Those are all small little reasons of why you wouldn't get 648 in this problem. Now the next one, they don't spoon feed me everything like they did in 1 and 2. Here, what's the 13th term of the sequence? Okay, so n is 13. Then they give me the geometric sequence. So I have to pluck out my first term. My A1 is 8. Now, what's different about this one is, notice they did not spoon feed me what the common ratio is. That means I have to do a little bit of work and I have to find out what the common ratio is. I know it's a geometric sequence, so I really only need to test out 2 terms to find out how did I go from 8 to negative 16. And that is I'm multiplying by negative 2. If you want to test out a second one, then test out a second one. Make sure that you'd be multiplying by the same thing. Because if you're not, you did something wrong. They've already told me it was a geometric sequence, so I know that it has to be the same thing for all of them. So now my common ratio is negative 2. So now I'm going to go ahead and plug this into the formula. My first term is 8. My common ratio, I solved for it to be negative 2. And then my n is 13 minus 1. Again, I'm being dramatic by writing out 13 minus 1. If you're fancy, you could maybe do that in your head before and just do it in your first step and do some of the work yourself. So now you're going to type this in, and what do we get? 8 times negative 2. Make sure that negative 2 is inside the parentheses and it's being raised to the power of 12. This one, rather large number, larger than what we're used to with these ones, but you get 32,768. Now the last type of problem is word problems with geometric features. So I had to do a little cut and pasting for this one from the textbook because the picture is, we need the numbers in the pictures. Now, normally when I teach this lesson and this particular problem, I do kind of poke fun at the fact that this girl is bungee jumping off this bridge. Her friends are like, ha ha ha, look at you. If you look close enough at her bungee cord, which is right here, and mind you, this looks like very, very flat, like desert land. If that was stretched out, she totally would have smacked the bottom of the ground and possibly be dead or decapitated. But I guess they should have drawn that a little bit shorter, but I tend to nitpick. And if you're going to draw this picture about bungee jumping, you better be a little bit more accurate with the actual bungee cord and make sure that it's not this long to show that this poor girl would basically die had she bungee jumped off this bridge. And then her three friends are like laughing up at the top, or I don't know, will be crying at the end of her bungee jumping. But anyways, and then also behind her is like the ghost of her to kind of show you, see, here she is and here she is, that she's like bouncing all the way back up and coming back down. Not a chance. If this was an actual problem, it would not work out. But for mathematical purposes, we'll pretend this is a happy problem. And this girl and her friends just went out for a nice fun time to go bungee jumping, because that's what we do to have fun with our friends. Okay, so my three terms, I've got 200, 80, 32. That's my sequence. 200, 80, and then 32. Now, my what do they want? What is the bungee jumper's height at the top of the fifth bounce? So n equals 5. I've got my A1 based on the picture, solely from the picture. They didn't put it in words for me. So from after the first bounce, she bounces all the way back up to the 200-foot mark. Then what I'm missing here is my common ratio. So looking at the sequence here, I have to figure out what the common ratio is. So to find the common ratio, this one's not going to be the prettiest common ratio you've ever seen in your life, but 80 over 200. When you divide that, it's 0.4. So the common ratio is 0.4. If you'd like to use 2/5, you can do that as well. I'm going to go with 0.4 on this one. Okay, they want the fifth bounce. So again, using the formula, 200, then I have my common ratio of 0.4, the power of 5 minus 1, 200 times 0.4 raised to a power of 4. That is going to give me 5.12. Realize that, going back to me poking fun at this picture, after the fifth bounce, she is only 5 feet. She's dangling from this bridge of death. Only 5 feet. Okay? Most of us aren't, we measure, that's how tall we are. To be 5 after you just bounced up and down. Again, the author of this book should have done a little bit better with their numbers here, because each time your weight is going to drag you down a little bit longer, and that is not enough room for me to ever want to bungee jump. Even if there was water instead of what looks like the desert there, water is would be just as bad because you're so high off the ground. But anyways, there's my lecture on bungee jumping. Don't do it, especially if you don't know the math behind it and you can't figure out your bounces and if whether or not that cord is too long or too short. Okay, so let's go on to happier problems. Okay. Number 2, the table shows a car's value for 3 years after its purchase. The values form a geometric sequence. How much will the car be worth in the 10th year? So this is kind of sad when you think about how much cars are worth and how much they do depreciate. If you've ever heard the term that, like, when you drive a brand new car off the lot, it already depreciates, several $1,000s because people don't want used cars. They're going to pay top dollar for brand new cars. Anyways, look at this. The value, again, poking fun at the author here. After 1 year, the car that they bought is only worth $10,000. There are no cars out there, brand new cars, that cost you $10,000. Okay, the cheapest, the smallest little 2-passenger smart car is not even going to be $10,000. There are golf carts that cost more money than this car that they have in this example. So just a little food for thought there about what our prices are like now and how this book is a little out of date when they come to prices here. Anyways, they want the 10th year, so that's my end value. My first term in the sequence is going to be the 10,000. That's year 1. Then my common ratio. Again, I've got 10,000, 8,000, and then 6,400. So to find out what the common ratio is, I'm going to do 8,000 divided by 10,000. That is going to give me 0.8. So my common ratio is 0.8. Now the easy stuff is plugging it into the formula. I've got 10,000 as my first term. Common ratio is 0.8. And I've got 10 minus 1. 10,000 times 0.8 raised to the 9th power. This is going to give me $1,342.18. For 10 years, you're driving a car that is worth $1,342.18. At least it's worth something and you're driving it around. But make sure that you can get that in the problem. Notice I was rounding to the hundredths place. I rounded the hundredths place here. We're now at the stage in the game where if it's not a whole number and they don't have it as a fraction or they don't want it to be a fraction, you should go to the hundredths place. Now, what I want you to do is I want you to attempt to do on page 621, numbers 2 through 7, all of them. It's an example of each of the problems that we did, and then in a little bit we'll meet back in Zoom and we'll discuss those and make sure you know what you're doing. See you in a bit.